Hello guys, welcome to my YouTube channel, and from today I will start a series of lecture on mechanics. Before we have to know what is mechanics. See, mechanics is the branch of physics in which we study about the motion of a body. You can also say mechanics is a branch of physics in which we study about the motion. Mechanics have two parts, kinematics and dynamics. What is kinematics? Kinematics is a part of mechanics in which we study about the motion of a body without going into the reason behind the motion. We study about the position of the body, velocity of the body, speed of the body, acceleration of the body, but we don't go into the reason behind why the body is in rest or why it is in motion, and why the acceleration of the body is this or that. So we do not go behind the reason of the motion. We only study about the position, velocity, speed, acceleration, and we establish a relation among them. But we don't know about the factor causing them. So this is kinematics. Now what is dynamics? Dynamics is the branch of physics in which we study about the motion of an object, and we also study about the reason behind the motion. So the dynamics is the branch of physics in which we study about the reason causing the motion. So from today we will start kinematics, and after it finishes then we start dynamics. So let us start kinematics. So in kinematics, the first thing we must know that what is motion or what is rest. When we call that a body is in rest, and when we call a body is in motion. For example, this is a marker, and we have to find whether this marker is in rest or it is in motion. Say, what is the definition of motion? The definition of motion is, if a body changes its position as time passes, then it is said to be in motion. And if it does not changes its position as time passes, then it is at rest. For example, see, this is the marker, and time is passing, time always passes, and as the time passes, this marker is not changing its position. I can see that this marker is not changing its position. So this marker is in rest. Now, as we can see that as time passes, the position of this marker is also changing. So this marker is in motion. So when the marker does not change its position as time passes, then it is at rest, and if it changes its position as time passes, then it is in motion. So this is difference between rest and motion. Now let us again see this marker. This is at rest according to me, because I can see that it is not changing its position as time passes. Now suppose there is a person which has standing on moon, and it is possible we can go to the moon, and let us suppose that a person is standing on moon, and from moon he is observing this marker. And if you go on the moon, then our earth seems to be moving from the moon. So if a person observe this marker from the moon, then this marker seems to be moving, because earth is moving according to him, and this marker is on earth. So with the earth, this marker is also moving. So what does that person standing on the moon says about the motion of this marker? He says that the marker is in motion. When I observe this marker, then I tell that this is at rest, because its position is not changing as time passes. But a person standing on the moon says that the position of this marker is changing, and so it is in motion. The question arises, what the actually situation is? Is this marker in rest or it is in motion? What is the correct situation? See, nothing in this world is in absolute rest or in absolute motion. Motion is a combined property of object under observation and the viewer. There is not meaning of rest or motion without the viewer. So a same body can be at rest according to one viewer, and it can be in motion according to the another viewer. So nothing is in absolute rest or in absolute motion, and the motion or rest of the body depends on the viewer and from where it is viewed. When I view this marker, then it is a rest. A person standing on moon view this marker, then it is in motion. So nothing is in absolute motion or in absolute rest. We explain it by another example. For example, this is a car going on a straight road. This is a person A observing the car, and this is a driver of the car C, and this is B sitting behind the driver. I asked A state whether B is in rest, state whether the driver of the car is in rest or motion. We can see that according to A, the position of the driver changes because the car is moving. So A says that the driver is in motion. Now the same question I asked to B. What B observes? B observes that the position of the driver C from B is always fixed. There is not change in any position of the C according to B. So B says that the driver is at rest. So the same driver is rest according to A, and in motion according to A, and is in rest according to B. Now suppose there is now I asked B that say whether A is in rest or motion. When B observes A, he observes that position of A is changing as time passes because the car is moving. So the position of A according to B will change. So according to B, A is in motion. Now let there be a tree on the near the road, and what B says about the motion of this tree? The position of this tree is also changing according to B. So the B is also in motion. So the tree is in also motion according to B. But according to A, the position of this tree does not changes. So this tree is in rest according to A. So the same tree is in rest according to A, and it is in motion according to B. All the things which are at rest on the near the road are at rest are in motion according to B, but are at rest according to A. Let us assume that there is another car. And this car is also moving with a speed 10 km per hour, and this car is also moving with a speed 10 km per hour. Now I asked B whether this car is in rest or motion. What B observes? He observed that the distance between or the position of this car with respect to this car is fixed because they are moving with the same speed on a straight road. So this car seems to be at rest according to B. But according to this car, both these cars move with a very high speed. So these two cars are rest according to A, but this car is in these two cars are in motion according to A, but this car is at rest according to B. So what we have learned? We have learned that a same thing can be in motion with respect to one object, and a same thing can be in motion according to another person or object. So this is rest and motion. Now we will study about the frame of reference. What is frame of reference? As I just said that nothing in this world is in absolute rest or in absolute motion. So motion is a relative property. According to one person or thing, body can be at rest, and according to another person or thing, a body can be in motion. No, so the person or the place according to which we decide whether the given body or thing is in rest or motion is the frame of reference. There are many methods of frame of reference, but a popular and very convenient method for the frame of reference is 3 Cartesian coordinate axes, x-axis, y-axis and z-axis. Now we attach a clock in it and this becomes the frame of reference. Then how can we decide with the help of this frame of reference that a body is in rest or in motion? Let there be a body. If all its coordinates, x, y and z coordinates, remains fixed as time passes, then this body is said to be in rest. But if any one of the coordinates, x, y or z, change it as time passes, then this body is in motion. For example, suppose I attach this frame of reference with A. Here I attach it with A, x, y, z. Now in this frame of reference, the coordinates of B and C changes as time passes. So this B and C and the car is motion. This car is also motion in this frame of reference because its coordinate will change as time pass. Now but the coordinate of this tree will not change in this frame of reference which is attached to A. So this tree is at rest in frame attached to A. Now if I attach the same frame with B, let be x, y, z. Now what happens? In this frame the position of A and this tree changes as time passes. So this A and this tree are in motion in the frame attached to the B, and this bus whose coordinate does not change as time passes as seen from the frame attached to B. So this bus is in rest in the frame attached to the B. So the same objects are in motion in the one frame and are in rest in the other frame. So this was the frame of reference. So guys, that's all for today. Thank you very much.